Hi everyone, this is another session where we continue to develop OData Neo. We're just waiting here on Mr. Sam Shoop, and I'm joined today by my friend here, Paul Wardy. Is it Wardy or Wardy?
My actual name is Paul Ward, but all my friends call me Wardy. It's a
Wardy?
sort of a
Okay,
nick.
that's like okay, Wardy. I like it. I like it. And what is the T Wardy?
Exactly.
That's just all right. Let's see. Let's see if we can pull Sam here. Sam seems offline. Why Sam is offline? He doesn't want to work with me today. Well, that's
He's run
interesting.
away. He knows
Well,
what to expect.
he's like, I'm done with this stuff. Okay, Paul, you had a great suggestion. You put that suggestion here in the group. Let's take a look here. Let me go if I can go to your suggestion here real quick.
I
Let's
just
go
wanted to
here.
sort of highlight the potential power in what you're trying to achieve here, because conventional web applications using the current OData framework
Mm-hmm.
tend to be really sort of configuration heavy, and there's a lot of sort of unknowns, and there's a lot of framework wrapped around everything that we're doing.
Mm-hmm. Mm-hmm.
Whereas potentially, if all we had was some thing that, like a magical extension that could
Mm-hmm.
extend an IEnumerable T, and you could just say, hey, here's my OData question that I want to apply to my IEnumerable T. And
Yep.
if I could pass that all the way down to my data layer, the general concept would be get it down there as quickly as possible. And then once it's down there, handle it so that I don't have things like all my entity framework logic
Yep.
leaking into my business logic layer and then
Yep.
ultimately having to be handled by my OData layer in the
And the
API layer.
controller. Yep. Yep.
Yeah.
Yep.
So if you think about how modern OData applications work,
Mm-hmm.
if I've got an OData query, I either have to have tight binding between my entity framework entities
Mm-hmm.
and ultimately my SQL server and my OData queries,
Mm-hmm.
or it generates so much overhead and so much work for us as developers where we have to sort of manually wire things up.
Yep.
So my thinking was that, like, if you conceptually had something that allowed you to apply that separation or manipulate things in a way that suited you,
Yep.
and because all you're passing down your stack is essentially a string,
Yep. Yep.
um, then you can apply whatever business logic you want in whatever layer you want, and you don't have to be concerned with, for example, entity framework leaking into
Yep.
that business logic. So
That's the most
from
dangerous thing I've seen people do. Like they're putting entity framework in their exposure layer API. I'm sorry. Go ahead. Go ahead first. I'll tell you later. But go ahead. Go
yeah,
ahead.
so exactly that. Like, whenever anyone who's familiar with using entity framework, whenever in your business logic, either in your controllers or in your service layer, essentially in your business logic layer,
Mm-hmm. Mm-hmm.
you're saying something like .include, that is
Uh-huh.
an EF specific
Yep.
extension.
Yep.
And I'm
Yep.
sure it's the same with other ORM implementations. Hi, Sam.
He said. Sam,
Anyway,
Sam just woke up. He's like, "Why did you set up this meeting so early, dude? That's just brutal."
it's
Sam,
working
Sam,
for a living.
Sam, should we shift our sessions to be around 10 a.m. or something like that? Maybe a little bit later. What time is it for you now, Paul? Out of curiosity, it must be a little late.
For me, it's for
Mm.
you, Sam. For you guys, it's first thing in the morning, right?
For us it's 9:05 here in Greater Seattle area. What time is it in England right now?
Oh, here in sunny old England, it's 5 p.m. So
Oh, okay.
late is probably better for me because I've got two young girls, which you can probably hear in the background.
Yeah,
So there's a lot of
yeah. You
shouting and
got
screaming
your
this
own.
time of night.
This is my investment right here. These big headsets is to basically completely, I was just talking to a buddy of mine. He's from Puerto Rico and he has a lot of these, what does he call them? Cuis. They're like they're frogs basically, and they're very loud, right? And then he invested in one of these and I couldn't hear him. And when your head just get programmed, you programmed your mind to listen to that and just tolerate it. I was like, wait a second, where did the frogs go? This is weird, you know. Anyway, it's just weird. But anyway, Sam, if this time's a little too early, I'll bring it down a little bit. 9 a.m. for me, meaning the day is over. I wake up at 4. So like 9 a.m. is like, okay, whatever is left, you know how I do it, Paul? Like I get all the work done really early in the morning before people wake up and start sending me messages and questions and meetings and all that. So I'd be like, okay, you want to destroy my day, go for it. But beyond 4 p.m., I'm done with everybody. Nobody talks to me. This 12 hours of my day that I try to put, into making sure people are happy and all that. It also works with my morning rituals and stuff like that. So I have to wake up really early and take care of that. But Sam, we're gonna write some code today. What do you think about that? You want to write some code with me? Let
Cool.
me
Let's
just
go.
let me just draw the map here, just so we understand. And I like that we are all here together, so we can just talk this over and see how things work. Okay, so here's what we're gonna do, Sam. We want to build a service, and this service is gonna be the filter service. This service will have all the filter magic in it. Think about this. I'm
Can you
building
zoom
my
in?
software to, huh?
Zoom in.
Oh, zoom in. Yeah. Do you see it
Yeah.
now? Okay. So here's your filter service, right? And what we want to do, ideally, the input for this service will be just raw OData, or just like Paul was saying earlier, it's just strings, just are streaming through your system end to end. And what we want to produce, and this is what I was trying to explain to you, Paul, the other day when we had the discussion. I don't want what I produce here from the other side of this service to be a .NET native expression. I want it to be a local model. And this is where we need to talk a little bit, you guys. So, Sam, in the current implementation of OData, you take that raw string and you turn it into an expression, right? But that's too heavily dependent on the operations that you get out of the box with .NET Framework and IEnumerable and all that, right? I want us to create a localized model because you are within this core area of your implementation where anybody could just look at that code and say, I can create the exact same model in Java or Python or whatever the case may be. And then on the outside, on the broker side of things, I can go and say, oh, maybe I can now map that into an iQueryable or an IEnumerable, whatever the case may be, which we will also implement. But we need to allow people to have these basic core ingredients of OData so people can actually, pick that up and run with it. So,
So are you thinking that the
mhm,
local model
mhm,
is like, say I have in my .NET libraries, I can
mhm,
have an extension method for an IEnumerable, and I
mhm,
can give it this model, and from
mhm,
that model, it can then construct the expression tree.
precisely.
So it's a kind of, this is technology agnostic
Yep, literally
at
just
this point.
exactly what I'm trying to do. Here's the thing, your technology, so the .NET space, the .NET world can only go so far before you start hitting the Pythons and the Javas and the Scalas, especially when it comes to data. Scala has a heavy dominance when it comes to heavy IO intensive data operations and all that. It's not very popular in the OOP world because it's really hard to read and understand. Some people even say Scala is a write-only programming language. It's very hard to read and understand. But for functional programmers, people who like functional programming language, they love it. It's just like Haskell and F sharp. It's just one thing. And you guys might have noticed C sharp is also headed towards that direction, started to take that functional kind of theme to it. So anyway, so what I'm thinking here, and Sam, correct me here if I'm wrong. So
Yeah.
this local,
Can you add another service? And like to understand the structure. For example,
yeah,
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 the order
hmm
by service. What about order by service output?
hmm
It's another
yeah.
model. It's the same local model.
Yeah, so see, here we go. This is the part that I'm talking about. So
Mm,
if you can ignore that part, you
mm,
will notice that I said, our OData Neo is
mm,
gonna have something called an exposure, exposure component, and you will have core components, and you have integration components or brokers. And this integration component is the part that you're thinking, the part where you go and say, I want to turn this into a something that's relevant to the .NET world, like an expression or an IEnumerable or whatever the case may be. Today, our current implementation of OData works like this. We have a component, we have a service, let's call it a service, right? And this service takes in OData query like this and produces an expression from the other side, right? But the problem with that is that if I want to have someone come in and say, well, this core filtering component is maybe not very optimum, and I want to change that, or I want to change this integration piece, you know, instead of it returning expressions, I'm going to have it return my own models, like a completely different model. Let's say, you know that some people have their own extensions and implementations of IEnumerable, so they don't want that native outside of the box .NET thing. They don't have that option. They can't do that today, right? Without having an open heart surgery where they dive into the actual core logic and things are a little. So this binding part that you're talking about, that's that integration piece that you're talking about, because that binding is a .NET specific. It's very specific to the .NET. Ideally, what I want to do here, and just like you guys, you know, just I want you guys to understand this. This is just R&D. We're playing, right? It makes sense in my head. We're gonna see if it makes sense on the compiler, and if it makes sense on the compiler, see if it makes sense to people, and if people are gonna use it or not. But what I'm trying to do here is that this core component needs to stay at all times, and this is exactly how I build most of these enterprise applications, at all times completely independent and autonomous from any and all external or native models at all times. How are we gonna do that, Sam? We're gonna need to come up with a name for that local model that I'm talking about. Something like, I don't know, I could call it OQuery or something like that. OQuery or something like that. And that OQuery is a local model to OData Neo that actually takes that particular raw string and turns it into whatever that model is. Okay? What do you think about that idea?
So it sounds like OQuery is like abstract search tree implemented in the OData library now.
Yes,
So it's abstract in-memory representative of the OData query.
precisely.
So filter service take the loaded
Mm-hmm.
from any client
Mm-hmm.
and pass that loaded
Mm-hmm.
and construct um,
An OQuery. Mm-hmm.
abstract structure.
Mm-hmm.
And so it sounds like the abstract tree, search tree, currently implemented in the OData library. What
Right.
do you think?
Right. What do you think?
Then the integration, the part integration can take the OQuery to
And turn it into
turn it to
expressions. Yes.
any
Yes.
expression.
Yes.
It
And
is what do you think?
that's exactly what I'm thinking, Sam. What do you what do you think about that idea? You know, we can try it. We can try
Yeah.
it a little. So let me just
Can you
ask.
add another service in between the loaded and the OQuery?
Yeah, of course. Like this core service will always produce OQuery, but what's gonna
I know.
happen?
I mean, can you add another service rectangle?
Oh, between raw data and filter
Yeah,
service?
between the
Of
loaded and
course.
the
Oh
OQuery.
yeah. Oh, we definitely will. You can put interceptors. That's the whole idea of this lake house pattern, is that you can go here and say, no, I want to subscribe to that event with priority. And I want to be like, you can add in here a processing service. And this processing service, what it's going to do, it's going to go and say, someone else wanted to do something right before that event actually happens. The whole serialization, I want to pick up that raw data and do something else with it. You know, something completely different. Absolutely 100%. That's the whole idea. So just so you guys, just to keep you guys in the picture here, ideally we're going to take all these services and plug them into this lake house pattern. And what's going to happen is that they really don't know about each other. This is another further abstraction from dependency injection pattern. And we're basically going and saying, here's a message that's coming in, and we want to set up, like the person that's going to be using OData Neo, they're going to go and say, I'm going to set up the priority for the components that I have in my system. out of the box, they don't have to set it mandatorily. But if they want to add a new processing service in here that goes and says, please process this message first before you put it back into the lake house, and then let our core services pick it up. In fact, actually, and I'll tell you that much, I want even this guy to be replaceable. Like if
Yes.
someone goes and says, "Hey, Sam and Hassan, you guys are awesome. I appreciate what you did. However, it's not optimum." And
Yes.
I want to put in my own implement. And believe me when I tell you, like these SAP solutions where people are processing millions and millions of records, they have to do their own caching and hack a little bit of around the implementation. And most of these big high demand services, they have to do a lot of infrastructure workarounds to actually kind of work with, or kind of alleviate the issues that they're dealing with in terms of optimization, because some implementations are just not fast enough for some people. Now let me throw another crazy thing at you. There are interop libraries. Do you guys remember IronPython? Have you guys heard of IronPython? A lot of people do these cross-programming languages implementation so they can leverage the power of an existing programming language that is meant for a certain purpose into an existing framework, right? So maybe, I don't know, there was also things like Jython, which is Java and Python. People do that all the time, right? If someone wants to come in and says, I want to leverage Python in the OData Neo.NET implementation, so I'm going to replace that core logic and actually plug in my own core component, they may do so. They may do so even in the NuGet packaging. Like from a marketing standpoint, I'm going to give people one package that just does the work, and then here's a bunch of little packages that you can come and replace with your own components. That's where I'm headed. Now, the real question here, Sam, is that what is this OQuery model is supposed to look like,
Yes.
right? So, this is where you come in, my friend. Just the design perspective and just looking high level. Let me just find the code here real quick, and we'll talk about this in a second. Let's go to OData Neo. There it is. Hello, Neo. I am the architect. I've been waiting for you. Okay, let's see how that's gonna work. Okay, so here is the Visual Studio. What is it, Sam? Tell me. Mhm.
So back to the Joe.io, the first picture.
Let's go
It
to
seems
Joe.io.
like we have the source code. We
Mm-hmm.
need a compiler, and the compiler compiles the source code into intermediate language is OQuery.
Mm-hmm.
And the intermediate language is not uh, running executable um,
Mm-hmm.
code. So
Yes.
any VM or any target machine can take the intermediate language, the OQuery,
Mm-hmm.
choose the executable link or executable
Yep.
query on
Yep.
the database.
Exactly. So it takes that intermediary language and turn it into an
Yeah.
executable
It sounds
that's
OQuery just
relevant to
like
the
an
framework.
intermediate language. So
Right.
so we can call it abstract. It's a high level abstract for
Yep.
the low audit
Yep.
string or audit query.
Yep.
Yeah, yeah.
What
So
what you're doing today with a string to an expression, I'm just
mm,
adding one layer in the middle.
yeah, I know.
Okay.
Yeah, go ahead. So let's see what audit query looks like.
Yeah, what does
What's
this
on your
OQuery
mind?
look like, right?
Mm,
So ideally we want to turn the raw string that's coming in from as an OData raw query. I
mm.
want to turn that raw string into, let me get a new branch here real quick. Just a second here, you guys, and then we'll do you feel, just a gut feel here, Sam? Do you feel
Mm.
anything that could block us from that? Because it makes sense to me, but I'm not, nearly half as smart as you. So what do
Uh,
you
uh,
think?
I spent some time today write some code
Uh-huh.
and have a pull request.
Yeah.
Maybe I can share something, but it's already. I think it's. Do you have some sample code, or can I share?
No. You can go ahead if you want to share some code. That's fine too. Yeah.
Yeah.
So you're thinking about this, like you're actively trying things out. By the way, just
Yeah.
so you guys understand, like O data to Sam, that's his day job. For me, I'm just having fun. I'm just be like, oh, let's rewrite the whole thing. See what happens. Go ahead, Sam. I'm listening. Go ahead. Oh, by the way, on Friday, Sam, Mike, and I are gonna do a session to talk about this
Okay.
rapid library. I never heard of it before, but they seem like to have some controls.
Yeah.
But we'll
Rapid
talk about yeah, let's talk about it on Friday.
Friday.
Right.
Okay.
Yeah.
Okay.
Okay, tell me what you have. Go ahead.
It's just a prototype. So just want to share the. It's just a combination from the current implementation from ONode library.
Let's do
So
it.
I put it in the pull request.
Nice. This is the binder service, the one that takes a string and turns it into
Yeah, yeah,
an expression. Nice.
yes.
Nice.
The example is here. So the um, anything is a service, right?
Mm-hmm.
I create a binder service.
Yep.
So take the string and output the expression.
Uh-huh.
So that's the final thing.
Yep.
But it's an interface, it's a service, so we can replace the service anytime
Mm-hmm.
from customer.
Mm-hmm.
Provide the default implementation. So
Nice.
any field service takes the string. We do a parcel.
Uh-huh.
So we get the abstract search tree.
Yep.
Currently, it's not implemented. I don't know how to that. It's just take the string and output the your OQuery.
Yes.
Sounds like
Yes.
field clause is your OQuery.
Yep.
Yeah,
That
I
that
don't
that
know
filter.
what maybe it's different in your mind. What you in your mind,
Yep.
but it takes the string and get output the OQuery.
Yep.
So we can stop here. It's just like we output the OQuery.
Right.
It can be anything. So far, it can using a field clause.
Yep.
While field clause is on the I call it the abstract search tree. So it's
Yeah.
just like it's a high level and abstract structure for the
Uh-huh.
ordered query.
Uh-huh.
And here also I also implemented the bind, so we can bind
Nice.
the abstract search tree to the expression. It's implemented currently in the OData library, but it's in different libraries.
Yep. Yep. Yep.
So here's a and generate a lambda expression.
Mm-hmm.
Just for
Mm-hmm.
example,
Mm-hmm.
for the test, I create a test like let's field name equal ABC,
Uh-huh.
and the field bind depends on the query
Query
parser
option parser.
and
Uh-huh.
the query node binder.
Uh-huh.
And when we call the bind filter, we can get an expression.
Yep.
So my query parser it's a current implementation. I just hard code the filter
Mm-hmm. Mm-hmm.
parser. So it's just output a high level abstract search tree,
Yep.
uh,
Yep.
and customer can replace
Yep.
I can replace the built-in query parser
Uh-huh.
and do anything. And also he can replace the field bind service. He can do
Uh-huh.
anything. And the output is like this. It's a lambda expression, and this is the lambda expression output.
Yep. Yep.
I just put it all together as an example.
Yeah, yeah.
Yeah,
Yeah, yeah.
what have done in the current audit libraries.
Yeah.
Most of so for example, pass the string to the abstract tree
Yeah.
is in the audit core library, the
Mm-hmm.
very low library, and bind the abstract tree to the final expression is done in the Web API audit library. and this test is this codes are
Mm-hmm.
put them together and have a whole solution,
Yeah.
and it could be different with your OQuery,
Mm-hmm. Mm-hmm.
but I just give you an idea that this
Yep.
is
Yep.
what we have done between
Yep. Yep.
other libraries. Maybe we
This
can
this
do
piece
other
that
things.
yeah,
Yeah,
this piece that you're building, Sam, that's the integration piece. I agree with you 100%. The only
yeah,
difference is that instead of us passing a filter, string filter to it, we're gonna be passing what? OQuery. That's it.
yes. So you can say it's
It'll
uh,
be even much simpler because
mm,
you're you kind of so you're doing two things here, right?
mm,
You're parsing the string
mm,
and tokenizing it, right?
yeah,
And turning it into an expression. You're doing
yes,
two things, but we're separating that into two responsibilities. The
yes,
other the other part, we'll take the string and make it an OQuery, and then we'll
mm,
take the OQuery and turn it into a so the string parsing is a completely separate responsibility. We're really turning that raw OData query into strongly typed,
mm,
value that we can actually work with directly and turn it into an expression if needed be. Just don't think C#.net. Think that
mm,
someone
yeah,
is gonna pick this up and say, okay, I can create my own O query and I'm gonna turn it into whatever. I don't know, Nick or Paul. What's the equivalent of IEnumerable in Java? Do you guys know? It's like an iterable, or something like that. They have their own kind of
mm.
expression over there. Uh, you're on mute, Nick. You're on mute.
Yeah, there we go.
Yeah, I think you're right.
I can't remember.
Yeah.
But
So they
it's iterable might be it as well. I'm not sure.
They've
they
got a
have
generic iterable T interface, which is the
that's
same as RI enumerable T.
right. So they have their own kind of thing, but also Scala have their own thing, even though they're running on Java, JVM, but also think about other languages like Kotlin and Go and all of these different languages. I know that an implementation of OData in Go will be faster than anybody. I know that for
Mm,
a fact, right? Because it's
mm,
low level, you're basically writing in C++. The
mm,
dude that built the language is the same dude, Thompson, the same guy that worked with Dennis Ritchie to create C++. So sorry, C, the C programming language. So I know that I want to open that door in there. Okay, now let's go back. So Sam, this is the integration piece. Keep that as is. Don't touch
yeah,
it because we're
it's
gonna come
it's
back
just
to it.
for reference.
Yep, absolutely. This is perfect. Now here's what I have, Sam.
Mm,
How are we? What's that OQuery supposed to look like,
yes,
right?
that's what I want to know.
So this is where you're gonna help me out a little bit, but I'll tell you what we're gonna do here. So I'm gonna go down here and says, here's a new folder. This is O queries. This is like a namespace folder, and then I'm just gonna create a class here that I'm gonna call O query. It's beta. We can name it whatever we want. It just seems like
Okay,
something. Yeah, it seems like something that it won't conflict with anybody else in terms of uh, in terms of naming conventions, I hope. So okay, so this is the OQuery
what
guide.
is the O mean open or that?
Open or OData or I mean OData, the O in OData is open
Yes.
and the OQuery is OData, so
Oh,
OQuery. I don't know, it sounds also like it sounds funny. Just wait for people who use like a really low resolution like that to miss the Q for the O. It's gonna be fun, just the kind of decisions we make and then we wonder later, why did we do it this way? So what do I need? I know that this O query needs to have a list of things in them.
mm,
I don't
mm,
know what these things are yet, but these things are like, let's say this O query have a nested. I'm gonna put this in another file, but just for a proof of concept.
mm,
Let's say you have O parameters like this. I'm thinking out loud. I didn't think this before I come to this.
mm.
So assume that your parameter has, let's say, something like, this is your let's say
Name.
yeah, let's say you
Uh,
have something like a name, and then you have something in here that's called O operation, and this is your operation. Is it an equal to? Is it you know how when we were talking about the ASTs and we were basically saying, here's my left hand, you know, here's the operation, here's the right hand. This O parameters will give you that. So this guy would be basically an IEnumerable of O parameters. Sorry, this should be a parameter. No, actually parameters, because it's two things. Yeah, yep. One sec. Yeah, it's something like this. And these are your parameters in the entire query. So your query has all of these equations hard-coded as parameters: left hand, right hand, and operation. You know what I mean? So I want to go here and say, okay, this is here a public class ONode, and this guy here is gonna go here and say this is ONode, and that's left, and this is O operation, like this, public class operation, O operation, like this. So that's my operation, and then this here, public ONode right. Love the machine learning and AI that's writing the code for me. Ridiculous. I didn't even say right. Did you guys see? Like, I didn't even say do right, and it just figured it out. That's scary, man. So anyway, ONode and then right, something like this. Are you talking to us, Nick? You're on mute. Still on mute. Now you're on mute.
I keep clicking this because I type doing my day job. So anyway, GitHub CoPilot has been amazing. The way that it knows what it is you're doing and then kind of adapt.
We lost him again. As soon as you said adapt, and then it just went. What's wrong with your headset? It's not the hoodie. I can tell you that. So it doesn't matter whether you put it on or not. You're on mute. Still on mute. Yeah.
Can you hear me?
Yes.
Now I can. Now don't touch
Yeah.
anything.
Sorry
Mainly
about
don't
that.
touch your hoodie. Go ahead. Go ahead. What were you saying?
The way that the way that GitHub Copilot like is able to predict, and you got to think about it like this, right? It's not. Yes, it has the collective intelligence of everything that's on GitHub, but the way that it takes that and applies it to your structure of code, right?
Yep.
So it knew like, oh, hey, I have some sort of node concept. There's no such thing as an O node. It's not copying some O node from some
Nope.
other repository. It knows that you're like, hey, I have a node. Typically, trees have a left and a right branch, and I know that they're, the types of that branch are going to be node. So it knew to adapt in that way, and the fact that it can do this on the order of milliseconds is mind blowing.
I was showing the other day someone, like I said, sometimes it's a glorified copy paste machine, but also it started to get into like, let me understand your natural language and what you're trying to do. And like, if you go like this and say public class student, like this, look, somehow it knows I need an ID. Somehow it knows I need a name. I didn't tell it that. It just figured it out, right? But it's
keep going. I want to see.
Okay.
Jason, keep going.
I don't know what JSON property it wants to do, but student ID. Look, it's copying someone else's work from somewhere. I know that. Anyway, it just gets crazy. Anyway, okay.
Are we wasting our time here? Is this going to write it for us? Is that what you're saying?
Yeah.
It'll all be JSON, but it'll be written for us.
It'll just write it for us. So okay, so back to this. So Sam, that OQuery could have a bunch of parameters, and a parameter could have a right and left node, and every node could have a bunch of nodes within it. So you could have an operation where you're saying, let me give you an example. Let's say you have a filter, right? And you're going and saying, or let's say something more complex, like you're saying filter equal name equal Sam, like this. What that basically means is that your right and left node will have something like string property, let's say string value, right? That's your value, or it could be in a generic type, right? And your operation should have like an enum, and this enum will be like your enum will be something like equals or larger than. I want to allow people to add their own enum operations as well, right? So let's say at any point in time people want to add in XOR. I don't know why they would do that, but let's say they want to add XOR in there, right? And we don't have that outside of the box. They'll just go and add an enum value and apply the operation to it. This is like off the top of my head. Your OQuery is working with local models. Their local models are expressions. You're taking that string that's coming in and you're mapping that into these operations.
Yeah, I agree. But I had to interrupt you.
Please do. By all means, you're the man. Tell me what's wrong and I'll accommodate. Go ahead.
No, not long. I try to share my screen.
Yeah, go for it. Go for it. Here's your screen. Go ahead.
Go back again. So also using my example
yes.
here.
Yes.
So I also mentioned that filter binder will take the string and output the filter clause.
Yes.
And the filter clause, you can see filter clause is
there it is. I see it.
Yeah,
is it a local model?
Single value node. And you can see single value model is a top level model is query node. It's just like your own node.
Yes. Yes.
And I have the binary operation node.
Yes.
Binary operator node. So it's a single value node. Binary operator has the left and the right.
Yep. Yep.
And we have the binary operator kind. It's your operation, or operation, something like this. And it's an enum. And we have equal, not equal, greater than, or equal, something like this.
That's exactly it, Sam.
Yeah.
That's exactly it.
So we call it abstract search tree. It's a tree. So for example, also have the constant node. It's replace the single quote and the sum. Okay. And also the single value property access node. It represents property name. So we have the name.
Yes.
So back to the here. So here I try to try to maybe
freaking Windows 11. That's good.
Go on. Why I cannot say? Okay, yeah.
Yep.
So it sounds like here's my example. So it output the we have the left.
Yep.
And we have the equal.
Yep.
We have the right.
Yep. What's happening? Yeah.
I have to replace my mouse.
Yeah.
And so sorry. So
Yep. That's your tree. Yep.
So it's like this one. So
nice.
The left part is the property access.
Yep.
And the right part is constant. So it's like that. This is like all operation.
Operation. That's right.
And it's a ONode.
Yep.
ONode. It's the same thing.
It's exactly the same thing.
Yeah.
Exactly the same thing.
So that's what you want, right? We can build that, and so far we have a lot of code can reference, and we can change the name. We can so far it's hard code, and we can expose it as a service.
Yep.
And let customer to implement their own node and change the default behavior.
That's exactly. By the way,
just for your reference.
Yeah.
So here also we can see we have a lot of node.
Query node.
Query node. Query node is the top level. It's like the
ONode base.
ONode.
Yeah.
By the way, something to something to be aware of. Like I wouldn't expect that all operators are binary. You may have unary operators.
Yeah,
this is a good point, Nick. But he's aware of it. He has.
I'm sorry. I'm sure you are. I apologize.
Yeah,
you're good. You're good, brother.
Yeah, we can have a unary operator node. We can have a lot of kind of node. So, for example, we have the single value node, property access node, something like this. We have constant node. We have in operator. We have node. We can have another. Customer can create their own node and implement that into the
their own kind of operation.
OQuery.
Yeah.
Yeah.
So okay. So here's what you and I, because we're almost at time, Sam. Our first deliverable then would be to in addition to setting up the model, we want to write a test that takes in a particular string, and I'm going to show you a little bit of randomization. How do you guys feel about randomization and inputs for tests? Do you
chaos monkeys? I love it.
Okay, awesome. Because by the way, like, there are also two schools of thought when it comes to using random data in your unit tests. Some people say well, you're not really testing a particular operation, you're testing behaviors, and that's the people that is for randomization. Say, I don't care about passing in Nick or Paul or Sam. I want to pass in a random value and see how my test would behave. And then the other school of thought, there's always a couple of school of thoughts. You have Python 2 and Python 3. It's like they split off and they decided to maintain their own versions of Python, and they don't like each other forever. So the other school of thought say, no, if you're writing unit tests, you want to be very specific about what you want as inputs and outputs, right? The problem with both sides is that there will always be cases that you're not aware of, right? There will be things that happen, because even when you're randomizing within a certain perimeter. You're only generating names within a certain length that have certain characters. You're still running into this consistent state of, you're still determining. It's not really random as you think it is. But anyway, let me go back to the...
Those things are not mutually exclusive, right? Just...
Yes.
OData neo tests unit, OData neo test behavioral. Do both. I mean, in the time that you've explained it, we literally could have written a test that has one, a fixed input, and two, a random input, and be done with it, and we'll have even more coverage.
That's right.
I think the way to look at it is that, imagine you were writing a converter that could convert, say, JSON to XML. That's essentially what we're doing. We're taking a string which has to follow a known sort of structure. So we've got our limits in the same way that JSON has a standard. And we're saying, hey, when we output this, we want an object model that matches our string. So although you can technically pump in any kind of random input that you want, structurally it has to fit. So
yes,
what you should be able to do from a testing point of view is say, hey, this random string that happens to fit the structure should match this equivalent model that happens to fit the structure, if that makes sense. Precisely. So that's where you're getting your, if you like, your reach in terms of unit testing.
Absolutely. Okay, let me write a test. I'm going to write a test, a quick test. Sam, it's very simple and small, and we can build from there. What do you think about that?
Yes, go ahead.
Let me actually increase the font on my screen here, just for people watching on their phones. I know someone will be just laying in bed, or in the bathroom, just sick and tired, and just gonna try to they're gonna try to be like, okay, what's out there? Just surprise me, entertain me. Okay, let's see here if I can. So okay, this is super large. Let's minimize this a little bit. And then okay, so I'm gonna put in some operations. So I'm gonna go here and say this is OQueries, and under OQueries there's a bunch of things. I'm gonna create here ONode. I can create here O operation. O operation. The most important part about these sessions, you guys, is that I want people to also see how we implemented this. So if they want to go back as a reference and see how did these clowns do this, what did they do, why are they doing it this way, at least there's a reference for them to say, okay, that's the mindset behind this. And then they might criticize or might say, okay, I understand why you did it this way. Let me now tell you a better way to do it. So okay, so this is a node. And there's an operation, and the operation, we can make the operation like I can go here and say operation. Okay, so this is another folder. Let me go here real quick and create this folder here. All operations, and I'm gonna take this operation under this guy, and this is all operations. Okay, and this operations guy is gonna have something called an O operation kind. That's the one that you were talking about, Sam. And this guy will be an enum. And this guy, we can start with something as simple as equal. Just one thing at a
I
time.
wouldn't make an enum. Because if you're thinking about like the way that it could be extended, you could potentially bind that to a string. As long as you do case insensitive match, that's where you get your extensibility from.
Right.
So if you've got an enum that's built into the framework, these are the only operations that you can support. Whereas if you're just saying, hey, I'm going to do string matching, and I'm going to find an operation that has some parameter that when I do a string match, matches up with it, then I can say, hey, that operation is the handler for that piece of the OData query.
Okay.
So at this point, like if you've got an enum, do you see what I mean?
Yeah. So
we can add the enum item as customized or extended. So customer any new operation kind added. Any new operation added to the library, the customer can use in the customized enum member.
That's exactly what I'm thinking, Paul. Like, why don't they, like, ideally just staying away from OData Neo and everything? You want to take that raw thing and turn it into strongly typed, a value, an enum, an object, a class. Why can't they like extend the enum? They can, can't they?
I don't understand the Paul. So as I said, customer can create their own operation.
Yeah.
It could be any other symbol.
Yeah.
But the enum, if you finish the enum type, everything is done. The customer cannot add a new enum member to the enum type.
Yeah.
So as I said, we can change it using the string, or we can add a new enum member as ONode, or it's customized below the info.
So one idea I had was like,
go ahead.
Say in your O operation base class, you had like string operation name or something as a property. Then you could literally put anything you wanted in there. So if I then in the future want to extend and add new operations to this, I just take that as my base class, I extend it, I set that value, perhaps in my constructor or something, and then I implement my operation however I want to build out my O model or my O query or however it works.
So I apologize for interjecting. I would object against that. Like going back to what was mentioned before about functional programming, and it's not about a preference for functional versus object oriented. There are definitely advantages to having all the operations in one place. However, when you think about the goal of OData Neo, at least from how I interpret it, you think about .NET is a reference implementation. The implementation is going to be across multiple technologies and hierarchies. You are not necessarily always going to be dealing with a set of technologies or an implementation where the environment will allow you to couple these things in that manner. So I think it's best to kind of work from a base kind of like lowest common denominator, which says, okay, well, maybe I'm not going to work in an environment which has strong object-oriented kind of like, tendencies available to me.
Oh,
F
like you don't
sharp.
have the luxury.
Right. So
Yeah.
F sharp is going to like, it's not that you can't do it, but F sharp, like people who normally work in F sharp are going to look at this and they're going to say, well, no, because it doesn't work. Instead, yes, define the operations, define the attributes of the operation. I know that we can play semantics around what attributes mean, but define really the scalar immutable properties of that operation, basically a data packet, and then funnel that data packet through a pipeline, right?
Yep.
So when you want to interpret how the operation behaves, have a separate thing that you can plug in where you say, okay, here's the operation, here are the expressions that are related to the operation, do the thing, and then give us the result.
I like that. So do you guys go ahead, Paul? Go ahead.
So
Go ahead.
are you thinking like make the operation data rather than metadata?
The operation, it's all data.
It's all
data that passes through a pipeline where you can interchange the pieces of the pipeline, however you want to make it do what you need it to do.
So you don't extend operation.
Exactly.
You just make one.
And you fill in its properties, and then that becomes part of your binding information, if you like, as part of
Damn, Nick, that's good.
I've done this for a bit. I've done this for a while. I told you I am old.
What do you think about that, Sam, Paul? What do you guys think? So what he's saying, just to show you, I'm freaking talking about the lake house stuff, and this is even better than I could say.
That's what
this is literally.
Stick to the design.
Thinking about OData in the same way that we think about link, because it's the same kind of problem, isn't it?
Yes.
What you've essentially got is a functional model. So it kind of does make sense to think of a query as being like an expression tree or a function tree in some way.
Yeah.
So the key thing here is, as Nick says, make it as extensible as possible, but without assuming anything that's particular to a particular language. So the only kind of base assertions we can make is that we're doing something functional.
Yes. By the way, just so you guys understand, I come from Scala background. Like a lot of people look at me and be like, "Oh, he's the .NET guy," but I'm actually a Scala guy. But people don't know that yet. Not just yet.
So you're the one guy that uses Scala, right?
Let me tell you something funny about Scala. If you look at their logo, it looks like a kind of swirl, kind of a tornado thing. It's actually like they ran out of ideas how to come up with a logo for the language. And then they had a staircase that's just going up like this in their company, and they said, let's just make that the logo. Let's just for the people watching us, let me just show you what Scala logo looks like, and you'll understand. It's hilarious. They basically went and said, okay, these logos and names are really overrated. Why would we need to do that? So they went and did this. This is literally the staircase that they had, and they were like, okay, that looks good enough. So anyway, let me
touching on the abstracting operators and whatnot. This kind of highlights one of the things about link expressions that is not a bad thing necessarily, but link if you think about it, we need an AST, right? We need an AST so that we can be platform agnostic as the query is ultimately transformed into something that implementation will use.
Yep.
The thing with expressions, and it's like 99.99% of the way there, is that there's not a consistent serialization format for expressions. Otherwise, if there was, you're done.
We're done.
And then all of a sudden the .NET, I mean, I'm not saying you could be done, but the thing is you all of a sudden have a type system, right? Your type system is baked into the expression system, and you have a serialization format which you can share across the process boundary or across, implementation boundaries, which say, okay, here's how it is. They may not like it, but at least it's there and it's consistent, as opposed to having to develop this from scratch, right?
Yeah.
And on top of that, the extensibility story is kind of sort of not there if we, based on like custom operations.
Right. So Nick, let me try to summarize what you just said, because I like that a lot. And let's just see what Paul and Sam has to say. He's basically saying, let's say you have this new XYZ operation, right? This is XYZ operation going, and you're building your own customized XYZ service, and you're plugging that into your, into the lake house, right? The message that's coming in is looking for someone that adheres to this specific operation. This guy is coming with its own implementation. It could be a shim on top of a Python library that is just wrapped up in a .NET, so the inheritance part or extension part is not going to help you here. But also, if you want to add a new operation, it doesn't matter what these guys subscribe to as core libraries or not. This library can come here, plug into the lake house, pick up the message, process it, and then spit it from the other side as an expression, or spit it from the other side as an OQuery that can be translated into an expression down the road with an integration component. The beautiful part about this is that you can also extend your integration components. And let's say the existing out-of-the-box integration components say, I don't know how to convert this into an expression. It's not in my vocabulary. Cool. I'm going to add in my own component, which is XYZ broker, that will pick up whatever this guy spits out and takes it and then turns it at the end into whatever .NET implementation that fits the engineers working on the project. This way, I'm literally giving the engineers Lego pieces. I'm telling them, here's all the Legos, or go get your own. As long as you can fit it in, it'll work. So what do you guys think? How do you feel about that? I don't know, Nick, did I express that right? Is that what you were trying to say?
I think you got the most.
Yep.
The idea basically, is that like it's all too easy to fall. And, when thinking about something like OData that's supposed to be implementation agnostic, is sometimes all too easy to fall into the trap of leaning too heavily on the things that .NET and C# will afford us.
Yep,
One of
that's
those
easy.
Things
That's
is
just lazy.
Yep, right?
Yep.
Don't get me wrong. Object orientation is very prominent, but it's not it's not necessarily. Other ways of doing it are not necessarily non-existent, and they will be important players in this. So it's something to keep in mind.
Yep. By the way, you'll see a lot of the implementations out there. A lot of engineers will build systems and objects and classes like as if they're not biodegradable, like they're gonna live forever. But in reality, as soon as you start as soon as you start using it in a real world enterprise level system, you just end up writing your own. And that's just not okay. I want to tell people, I know you're gonna rewrite this. Here's how you do it. Okay.
Could not agree more.
All right.
It really bugs me when people that provide me with framework like assert that this is the way I'm going to use it.
Yep, this is how you're going to do it. Because we're smarter than you.
And then you find that one scenario, and you always find that one scenario that just doesn't fit. Just,
I was talking to Daniel Roth yesterday, the guy that does the Blazor system, and one of the things I really appreciated about him, he said something to the effect of, we're building the framework, we're building the core libraries, but there is no way for us to know how is this going to fit in until the community adapts it and runs with it, and then comes back to us and tell us, here's our business case, here's how we used your component, and here's the limitations. So now think about this for a second. What if the community didn't even have to go back to the core engineers or core developers of the library, and they are, naturally, spinning up their own components to plug into that existing framework so they can leverage the rest of the benefits of the framework without having to worry about going back to the core team and waiting for the next release, because that could delay other people as well, right?
Yeah, I'm of the opinion that if you have to spend more than sort of 5 minutes explaining a block of code, it's probably too complicated.
It's too complicated. It's too complicated. You'll notice
you've got one or two scenarios, right? You've either got an inexperienced developer, or you've got way too much complication there.
But by the way, I lived through a period of time, and I think Nick might relate to this. There was a period of time where people wanted their code to look hard, because that's how people know you're smart. You're showing off. You're literally, what do people say in America, Nick? They say flossing. People don't say flossing anymore. Not the flossing,
No,
flossing like showing off. So
wasn't there? I can't remember who it was. Somebody said, "Oh, if you wrote code to the best of your ability, then by logical extension, you're not good enough to debug it or something, because it requires a higher level of skill set to debug code than it does to write it in the first place."
Mm-hmm. Mm-hmm.
Yeah,
so in theory, we should all aim to be writing like dead simple code, so that when we do get a problem with it, it's not by extension a pain in the ass.
I mean, one of the I don't know the specific site, but I want to say there's a quote out there or something. But like, we read code 10 times more than we write code, right?
Yeah.
If you talk about like interpreting what you've done in the past, pull requests, pull reviews, all that, other people who maintain the code beyond you, readability of code is super important. So, I mean, I come from I have this horrible habit. I comment almost every line of my code. I drive people absolutely insane with it. I've tried to be better in the past. I don't believe in the myth, in my opinion, the myth of self-documenting code. There's no such thing. Code captures the how, it doesn't capture the why. And the why is super important in understanding why.
Yeah.
That's my opinion. I apologize. I'll get off my
No. You're absolutely right. I also have a hybrid approach. Like, some code can be commented and some doesn't. Like, if your code is hiding behind proprietary system that you don't see the source code of it, so what you just said, I swear to God, Nick, this is so scary, man. It's like I'm looking at myself in the future, because what you just said, I swear to God, word for word, man. This is why I always tell people, I say the code will tell you how it's doing what it's doing, but it won't tell you why. It's like the key maker from the Matrix, since we're on the theme and saying Neo. The key maker he's gonna make you keys. He doesn't know why. He's making you keys. He doesn't know why. He said, I fulfilled my purpose. That's it. Why you're doing it? What are you gonna do with that key? Good luck, my friend.
Have you ever considered that I may be a future version of yourself that came back to help guide you?
There you go. And then we get into that Dwight Schrute, Jim Halpert sending me faxes from the future to the office. Yep. Why not? Let's do that. Don't drink the coffee. It's poisoned.
The only problem I have with comments is that obviously comments can lie, because over time the code base will change.
You need to keep them up to date. There you go.
And code can't be wrong, right? It either works or it doesn't. And in the case that it kind of works, you'll normally have unit tests that show that it works.
Yeah.
But just because a unit test passes, it doesn't mean that the comments that are in the method that you're testing actually make sense anymore.
Yeah.
So there is a fine line to be drawn between kind of a comment being useful and sort of functional in some way and serving the developers some sort of service, and it just being there and being kind of an eyesore or like not being helpful, and in some cases actually leading to the wrong conclusion. So I always have this like really mixed bag of feelings about comments. I feel like if I have to comment my code, it's probably too complicated, in which case I should break it down.
That's I know exactly where you're coming from, Paul. I believe that 90% of the time, but then there are always cases where you just have to do something else. So anyway, let me just do this operation kind. I'm gonna give Sam a nice failing test and see what he does, because I wanted to show you guys like this pair programming where you're submitting a failing test and then he's gonna make it pass, and then he's gonna need to give me a failing test, and then I have to make it pass. That's a kind of ping pong kind of situation that we have. And let's see here on the node as well. Sam, you said there are constants and there are in the node level you have a string value, something to that effect. And you said the left side is different from the right side because the left side is a constant and the right side is a variable. Is that how you explained it, Sam? Is that what it is? Let's see.
No, ONode can be a top level abstractor. So we can have a constant node class derived from ONode. And the constant node can have the string.
Right.
And we can have a binary operator node, and the binary operator can have the left and right. Left and right is the ONode. It can be any node. Right? It can be any constant node. It can be any binary node again, binary operator node again.
I love it. I love it. Hold on. ONodes. So this is your ONode. This guy, and then you can have. Hold tight, Sam. We'll get to it. Do you have
binary operator node?
Binary
operator
node. Okay.
and write from ONode.
Yeah. So here's ONode. And this guy is your, no, wait. The binary operator that you're talking about is the operation, right? The one that's
No,
equal.
So binary operator, it's a node. It's
So,
a node.
okay, so that's the filter, select.
It
Is
can
that
be anything, right?
okay?
Think of it
Okay.
as A plus B. The A and
Yeah.
the B are the left and the right. The plus is an operator, so they're all variable.
Yes. Yes.
So you're gonna have an operator, and then
Yeah.
you're gonna have a left and a right.
Yeah. So in the operator node, we can have a property name left, and the type is ONode, and then have another property name right, and the type is ONode. So because the left and right can be any node.
Yep.
And the binary operator should have a binary operator kind. It's a string. It's a it can be anything.
So what's that kind? Is that the equal, greater than?
Equal, greater than, something like this.
That would be the operation. That would be this operation, right?
Yes. Yeah, you can put the operation kind into the binary operator node.
Think of it like you're building a language parser or a compiler.
Yeah.
You're saying, hey, a statement has 3 pieces.
Mm-hmm.
It has a left piece, an operation, and a right piece. And you're normally doing, say, an assignment or something. So you have like the destination and the value on either side of your operation, which is your equality.
And Sam, yeah, right. That's right, Paul. And you want to treat all of them as nodes, Sam, right?
Yeah.
You want to treat all of them as nodes. Okay.
Yeah, you can think if we have a dollar order by, and the expression of the order by is a node. The node is a property access node, the property node.
Hang tight, my friend. You're really fast and smart, very smart. So this is O operation node. What do you think about that?
I'm curious as to why you split the O off the. Where you had ONode, I would have binary operation ONode.
ONode.
But you went binary operator node.
I like it. Binary operation.
I'm just curious as to why you went with that. Yeah, why you moved the O over.
Just thinking out loud. That's actually coding out loud. Coding out loud. That's it. So okay, binary operation ONode, and then you have O operation node. I guess that would be operation ONode if I'm gonna play consistent here. So this would be operation.
Yeah.
ONode.
We can change the name.
Say ONode.
Sorry,
I hear oh no, oh no. And there's a very popular theme on what do you call it? Thing on TikTok right now, like, oh no, my table, it's broken. I can't stop thinking about this.
So what do you think, Sam? Operation left and right?
Yeah, we have the left, right, and we should have the operation kind for the left and right, and put it then as a node. It can be for another node.
Right. So this binary. So hold tight. So this would be something like, this would be filter.
Mm-hmm.
No. Wait. This will be name. And this would be Sam.
Yeah, something like this. It's a string.
And then this would be
equal or
EQ.
Yeah, EQ. So we should it's a kind.
So it's a kind, right? Yeah. Do you expect your operation to be? I'm just trying to think of the possibilities here. Okay, fine. Instead of calling this an operation node, you still want it to be an operation node, Sam, but it has a kind, like an O operation kind, like this.
What's the operation node mean?
It's just another node in your tree that contains the type of the operation that you want to execute. And we're doing it this way because you want to treat everything as a node. So you're giving everyone the freedom to do whatever they want to do with that node. Because I am sure that there is someone out there that will go and say, oh, I also want my operation node to have this thing in it, in addition to the kind. Right? I don't know what it is, but you're designing an SDK. So you're not thinking about what you know, you're thinking about what you don't know. What was this guy, Nick, have you ever watched, Donald Rumsfeld, the guy of the Department of Defense, saying there are known knowns, known unknowns, unknown knowns, and unknown unknowns. And these unknown unknowns are the ones where if you're a software engineer, these are like your boogeyman, right?
Yes, this is Donald Rumsfeld. He used to be he was Department of Defense, right?
Yep.
There's the known knowns. There are things
Yep.
that you know about. There's the known unknowns. There's the things that you don't know about. There are the unknown knowns, the things that you do not that
people
you're not
know
aware
about.
of that you know. And then
that's literally everything in Sam's head. There are unknown knowns.
The unknowns, and those are things that you should be truly scared about.
Yep. These are the ones that scare me personally. I don't know. Someone's going to pop up and say your entire implementation doesn't work for us. Why? Here is a very legit $10 billion business case that you didn't account for. Yikes. Okay. So this is what I'm doing, Sam. So you have nodes that are left and right, but you also have operation node. If it was up to me, I would go and say this operation node can inherit from ONode like this. Let's see if that makes you happy. And then we can go into the operation node and just say this is an ONode as well. And it can be anything you want. What do you think about that, my friend? Sam's face expression is like, this sucks. Tell me, Sam, what do you got?
Yeah.
There he comes. Here he comes. Wait for it.
Yeah, I know. So ONode
I love you, Sam.
Node,
you're a problem. Go ahead. Go ahead.
What if you went more abstract and you just said, okay, a complex node was a node that had multiple component parts. So it's an array of ONodes. And you could construct them however you saw fit.
Oh, I like that. So Sam, instead of saying binary operation nodes, you're basically going and saying, no, I want to make it a little bit like Paul just said, make it a little bit more abstract, man. Let's go and say, maybe we can build our structure in a way that can support both binary and any other operation. What do you call it?
I was thinking more about what Nick was saying earlier, how like everything that we describe in metadata is going to some extent be leaning on what we know about object orientation and the C# way of working. Whereas if you make it more abstract, you're basically saying, hey, it's flexible enough that if you want to define it differently, you can, and you lean on the features of your language to do that. So if you had something which was essentially just a complex ONode, a complex ONode could effectively just be a container for a set of ONodes, where an ONode could just essentially be a container for a value, which is a piece of the expression. Does that make sense?
Yeah. But do you still? But wait, Paul, you're breaking my brain right now. You're saying this complex ONode could be a bunch of nodes.
So yeah, think of the ONode as the base thing, all right? And then the complex ONode is a container for any number of base things to build an expression. So a complex ONode could translate to a line of code, like a link statement.
Yep.
By some kind of translator that could process complex. But it could also be a container for, say, an ONode with children.
I mean, this is what the current link expressions library does to some degree, but it provides strong structure around what each of those expressions is. And I think you're going to need that in some place, because I don't know of any place where it's just, a set of statements. And if you look at any kind of, abstract tree over anything, I would almost put this as a challenge. I'm not doing this to be defiant, but can you show me an example of another AST somewhere where it's just like, here is a random, or not random, but a non-ordered list of, expressions or whatever, and they are all valid in some other context. Now, maybe some languages and ASTs have that concept, but I don't know where that would fit in here unless you had some context to say they are valid within this operation, this other very well-defined situation, right? And it's that well-defined aspect that I think is missing from there. I mean,
I
yes,
just,
you could collect it like that, but what purpose does it serve, right?
I just had a crazy idea. Hey guys, just based on what Nick and Paul just said, just right now, check this out, Sam. Why don't you build two lists? Two lists. One will take nodes, and one will take operations. And then you're sending that as a query, and you're saying between every node and the other, pick up the operation. It's equivalent of an operation. Would that work? So let's say you have, let me give you an example. Let's say you have a name, that's node, and then you have Sam, that's another node, right? And you have a let's say a name in here, and you have Hassan. These are 4 nodes sent over to your query. And then down here, you have an operation called equal, you have an operation called and you have an operation called equal. And you're filling in the blanks between these nodes here. So the output would be name equal Sam and name equal Hassan. So you don't have to even think about it as a tree anymore. What do you think about that? Yikes.
You've still got hierarchy, haven't you? Because in an OData context, thinking about your query, within your select, you can then have child filters, or within your filter, you can have child selects, for example. So you've got that tree.
And how to integrate them into the upper layer?
Yeah. So hang on. To Paul's point,
we need a structure to self-explained.
Yeah, no, I understand.
Anything other things for the upper layer to process. I mean,
no, I got you.
Yeah.
Let me just try to kind of address Paul's question. Paul, it would be something like this: name, and then Sam, and then node, and this node inside of it, it will have another list of operations within it. Right?
Yeah.
So inside that, like think about this. Think about these two things as one node, right? Or one complex node, like you call it, right?
Yeah.
And this complex node can live within another complex node that says, something to the effect of here's excuse me, here's something like age, right? And you have 10, and so age 10, and then you have node. This node here, this guy here is this guy, this entire guy here, right? And then under operations, you're going and saying equal and. So your output, your true output would be something like this. Look at this. It would be age equal 10 and this whole guy. Like this. Would that work? That's very easy. Much easier to understand.
Yeah.
And you don't have to worry about right or left or up and down or any of that stuff.
From the top layer, it's still a tree.
Right, but it's much easier. You don't have to worry about right or left or any of that stuff. You're just giving me a list of nodes and list of operations, and you're filling the blanks.
Yeah, Hassan's basically saying, here's an expression, and now I've added brackets, and those brackets effectively define me some level of hierarchy, and then within those, I've got another expression.
Yep.
And you can just then recursively add brackets to go as deep as you want to make your expression tree as complicated as you want it to be.
Yeah.
So this is how we relate it in C# terms back to expression trees.
I like that a lot. Paul, you're freaking genius. You're very smart. You know that. This here, it's just the inspiration, man. Like you have 4 brains of very senior engineers and one intern that actually trying to solve a problem. So Sam, let's throw away left and right. All of that, throw that in the trash. We don't need it. Okay, and
Yeah.
we're just gonna give you a list of nodes and list of operations.
So yeah, the only thing you've got to be aware of is, I think Nick had a decent point earlier where he said, hey, if you go too abstract, then it loses its value. So you've got to make sure that a node has enough in it so that you can determine whether or not it's, say, a reference to a property versus a constant.
That's the validation. We're gonna
but this
run...
is where we come to values rather than metadata. So data rather than metadata. Yes, it comes back to that point. If we describe everything as a unique node type, it's described as metadata, and then we're locked into the way C# works. If we describe everything as data structure, then we're not locked in, and it all maps perfectly.
I like that. Damn, that's a pretty good solution.
This is like one area where object orientation kind of comes into play. And you see it in like expressions, right? Every single reference to another expression is never to a typed expression. It's always to the base expression class, right? So binary operator is left and right. It's to an expression. It's not to a property expression. It's to an expression. And then that thing gets evaluated. Ultimately, you're going to need some sort of visitor pattern to go through and interpret all this, right? Like to handle those types. But that's generally what this is gravitating to.
That was my thinking. If the language is just iterating over that base thing anyway, why even define the children? Just put enough data into the base thing that you can say, hey, I know what kind of child this is.
Well, because then, I mean, it's nice to have strong guarantees about what it is that you're doing for a specific thing. That you could if you wanted an abstraction on top of the data model that expressed it in such a general terms, I wouldn't be against that. Like in I have nodes like interface, which says children and or whatever, right? But there needs to be, in my opinion, there needs to be something strong there, whether it's through a property or through the type definition itself. You can discriminate however you want, but there needs to be something there to say, this is what this thing is trying to do and what it represents ultimately, right?
Yeah, and the other thing to point out here is that when we use subtyping in the way that we're currently using it with things like expression trees, what we end up having to do when we want to analyze and break that back down later into something that we can then, use or apply or build an expression tree with, we then start getting really reflection heavy. And then, of course, the big arguments come out about how slow reflection is. So
it's slow, and it's
what you want to do is completely avoid all that.
Yep. I agree. So listen, you guys. Just as a recap, because it looks like we're a little over time, but as a recap, you don't even need that. You could just go and say, let me restructure this real quick, just for funsies. Let me restructure this. So the OQuery will have something called they're all nodes. So in here, this is let me just create this here. This is ONode. And this is a public. I love this a lot. This just makes I'm not that smart, you guys. You guys are making it so simple. This guy will have a list of I'm gonna make it an array even, because I don't even want to get anything at all from the
use IEnumerable. It's the real base thing. Yeah, because then it translates better to other languages.
Okay, so this guy here would be, so check this out. This here would be values, and this guy here would be.
So I would say that when you parse your query, you end up with a root ONode, which is the root of your expression tree, effectively. And then that will contain children ONodes. So an OQuery would have one singular ONode at its base.
Gotcha.
ONode.
ONode. That's what Nick was talking about. Nick was like, every time you say ONode, I think, oh no, and this guy basically has ONode as.
And then by extension, my thinking was an ONode would have a collection of child ONodes.
Yes, that's so.
some other
Like
things
this.
like potentially like a value or something that describes what it is, and possibly
So
like a type.
that's going to be a little problematic in my
Why?
opinion, right? So think
Why?
of it like this. So an OQuery has different parts where expressions play different roles, right? So
Right.
let's take the projection part, right? The projection part, there are two aspects to it. There's a value component and then there's a naming component, right?
Okay.
The ONode representation that you have now is very good at describing the value component, right? But it has there's no concept of defining the naming component of it, right? Because you can project a value into whatever name you want, right? That's the SQL. Think of the analogy in SQL is the select statement. It's the select part, right? Now, when you look at filtering, what is a collection of those values mean, right? Like, one, you need them to be of a Boolean, right? Because you're trying to evaluate, whether or not a particular.
Oh, you mean like an outcome? Yes. Yes.
You
Go
need
ahead.
an outcome, right? So you need some. You're going to need a little bit more. I mean, granted, again, you could have the ONode be representative in some way through a property or through typing of the actual, of how you're discriminating this node. But there need to be constraints, right? I'm not doing wrong. I absolutely agree. Like, I still stand by the statement of using data to be the representation of the AST. But I don't think that means that we should be completely schemaless in that data, nor should we, throw away, I think there are some core things that we may be able to take advantage of to make it easier in .NET that don't necessarily put other implementations at a disadvantage if we take advantage of those things, right?
Okay. So you're basically saying you're basically I saw the video that
what
Nick
I'm saying is
posted.
that at the top level, when you start looking at queries have very specific, like a top statement, you have to have a numeric outcome. So they have very specific requirements, right? Now, whether or not you want to codify that in the type of the query is up to you.
Why do we care? Why do we care?
You care because if
at this point you don't, because your OData query is just a thing that maps to the thing that you're ultimately going to produce. And if what you're producing is incorrect because the query is invalid, then your destination will tell you that as part of your broker integration.
Yep. The broker.
Yeah. So this isn't a query in a sense, or rather it is a query, but it's an unvalidated query. This is the result of the lexical parsing.
It's strongly typed query.
Yeah.
At this point, we're just tokenizing, right?
Yeah, that's it.
We don't want to produce anything from it. Once we've got our token solution effectively as a tree, we can then start the process of actually going through that and translating that through the broker into something that's language specific.
I have to say, though, there will be a tiny bit of validation, structural and logical validation that is going on at that level. Like, if you give me five values, and only one operation, that's an invalid operation. I will say invalid ONode exception.
Is it?
Okay, that's a great. Okay. I can hear your thoughts, but let me just tell you this. So imagine this. You're giving me something like this.
Think of query validation as being another service.
Okay.
I may have extended it, so therefore that may be valid for some reason.
But wait a second. You still have to stay true to the OData protocol.
Absolutely. So the stuff we would implement as part of the framework would only fit OData. But there's no reason why that couldn't be acceptable as part of some extension that somebody customizes into it. This comes back to, hey, the framework shouldn't stop me from doing something that's invalid or not to spec. It should only effectively prevent me from building an invalid link query, say, on the other end.
Because there is no guarantee you're going to build it into link query anyway. You could turn it into whatever you want. Like,
sure,
you could
that's
take that
your broker's problem, right? Which is a different service.
Yes.
So at this point, I would say, hey, pretty much anything goes. What we do with it and the eventual destination, that's the thing that decides whether or not it's valid.
So you're just tokenizing here, but whoever receives that token should have the liberty to determine whether that token is valid or not.
Exactly.
Paul, what do you do? You're scary. What do you... I like that. So, okay, listen, guys. So in this scenario here, if I go into just that normal scenario, that would be translated into values. Like the values piece would be, name and nick, like this. I typed your name in Serbo-Croatian, Nick. And then the operations here would be just one that says equal. That's what this translates to. So you'd have one node, one ONode, with two values and one operation. What do you think? Sam, do you have to go?
I have another call. It's okay.
Okay, so listen, I'm gonna wrap up with you. Just shut down that guy, join it in a 10-second. That's probably his boss, but 10 seconds. This is how we're gonna translate this to. Let's hang out tomorrow, Sam, and let's get it done. What do you think about that? All right, I like that.
Shout if you want any further input, guys. I'm always about.
You guys, yeah, around that time I will connect, and you guys please join us. Your brains are worth millions of dollars. You have no idea. You're very smart. You're very, very smart. I like that solution though, because you're flattening it. There's a tree in our heads. There's a tree, but in reality, it's flat. It's just 2D.
I think at any given level in the query, you're always looking at essentially a statement.
Yep.
It's
yep.
The fact that the statement has sub-statements is somewhat irrelevant, right? Because it's just recursion.
Let me throw another wrench at it. Why don't we make one IEnumerable with people determining the values in it, so you don't have to do that merge later?
Oh, yeah. I mean, that's how I presented it. I think I Discorded you potential.
That's what you sent? Okay.
Yeah. So my concept of an ONode was that you might have some kind of
the children.
Type thing,
oh my god!
Which I defined it as a string, but it might be something else. I don't know yet. Then you'd have some sort of value, which was a representative value of the current node, and then you just have an IEnumerable of children, which could be of any length, and then you just build that out. However you build that out.
And what did you make the children of type? They're also ONodes. So Sam, just so you see, instead of having all of this, we could Paul is saying just call it children. Get and set. And he said, let's have something in here. I'll just for the kicks of it, I'll say object, but we'll change that. He said, put a type in here and put a value in here. Oh, we're getting even better and better. And now you can go and say, why do I have two different sets when I can just have one thing called children? And children is basically a list of nodes. And these nodes, one of them will be like, value is name, and type is property or constant, whatever you like to call it, Sam. And then the second object would be value, right, is equal, and type is operation. And then the last one in here would be, you're literally tokenizing. You're just taking the query, and then in here you can say value is Sam and type is value.
Or constant.
Or I don't want to.
He calls it constant. Yes.
Like, throw other monkey wrenches in here.
Please do. Mm-hmm.
Have you considered talking to Rosalind team? These are like the lexical parsing is probably a solved problem for them, and I don't know how extensible Rosalind is to be able to do what it is that you're talking about here, or whether that can be leveraged to get to, at least for the lexical parsing. I'm not talking about doing the token analysis or maybe even they could do some, but I suspect that they may have a lot of input, if not existing code that can be used for this.
Absolutely. I'll reach out to them. The beautiful thing about this though is that you can have a type here that says nested, right, Paul? And then inside that guy you can have also children, right? That's an array of other nodes. Oh, you smart son of a gun.
Now imagine you've got a JSON blob that represents this structure.
Oh my god. Now anybody could just
Now you can build a web-based editor for an ONode query.
Yes.
See how simple this stuff gets. So my thinking was like reduce it to its absolute component parts. When I think of an ONode query, I think, okay, there's a root node. It's going to have some select node
Oh my.
as a child, which is going
Yeah.
to have its component parts, and it's going to have some sort of filter node, which is, you know, another child, which is going to have its component parts, and those may in turn have children that are more complex as well. But to my mind, yeah, that this is exactly the same as, like Nick says, it's a code parsing problem, right? But the code in this case is really simple compared to something like C#.
Yeah.
So in theory, yeah, if the Roslyn guys can give us any input on this, it is
I'll
a done
reach
deal.
out to them. I'll reach out to them today.
The only thing I would say with
ping the
OData,
boys and girls in building 25. Tell them, hey.
the only thing I would say with OData is it gets tricky with precedence, doesn't it? So I noticed in the existing OData framework that the order that things are applied in can sometimes matter.
Yes.
So we probably want to consider, like when we get to processing and building out this node hierarchy, that we build it out in the order it's defined in the query. So if it's defined filter first, we apply the filter. If it's defined select first, we apply the select. So it gives you different precedents, whereas the current implementation, to my understanding, is one of my biggest frustrations with the current implementation, is that no matter what order I give those parameters in,
it's just going to get, you know,
Sam's
by the way,
code is basically saying, right, it's going in this order.
By the way, just to let you know, there is some truth to that, but I am hoping that these nested nodes will take the priority in execution and materialization before you go up. So basically, it's the equivalent of doing this, Paul. It's the equivalent of going and saying 1 plus 1 plus 5 plus 4, or multiplied by 4 or something like that. So it will honor that at its own individual node before it goes up the tree and evaluates against these. At least that's how Sam
I
explained
was
it to me.
thinking more,
Yeah.
imagine an OData query where I've got a select and a filter, okay?
Mm-hmm.
And let's say that I've defined the filter second and the select first. So what I'm saying is, hey, go to this endpoint, get these properties, and when I've got this set of, let's say the object that on the endpoint is defined with 10 properties, and I'm saying, hey, select these 3 properties, and now I want to apply a filter on that set of objects that contains only those 3 properties. Whereas imagine I've done it the other way around, right? So I've got my objects that contain 10 properties, and I'm applying my filter. Now, where it gets even more confusing is, imagine that you've got a filter and a select nested, and side by side with that, at the root level, you've got the same thing going on. You can get drastically different results. And my understanding is that both of these scenarios are actually supported as part of the OData specification.
Yeah.
And this is where we end up with, I think I've had a ticket going for quite some time now with the original OData implementation. And I think it's just been passed down the chain, where you get things like apply, which does aggregation. And when you start doing aggregation and then you want to do, say, sub-selection or something on your aggregates, you just can't do it because the framework's not complicated enough to take into account that scenario. So my thinking was, but by reducing it like this to its like simplest component parts, when we come to do the query processing out of the other end, we just crawl the hierarchy however it's defined and spit out the expression tree equivalent of that hierarchy in the way that it's defined, in the order that it's defined. And if that results in an invalid link query, it's invalid. You know, that it is what it is, right? But if it's still a valid query, then you should be able to return an appropriate response to the call.
One of the really tricky parts about all of that is that so the difference between OData and things like, say, GraphQL is that with things like apply and groups and aggregates, what ends up happening is you're able to introduce a new type at query time that does not exist in, that OData, that nothing has any knowledge of.
Yeah.
Yes. Selection
and
does
then
that.
you need to do, and if you're going to
Select does
apply
that,
processing on top of that,
Yeah.
that presents like, so you need so that bringing that back all the way down to here, maybe not on the parsing, but when you get to the AST level, you're going to need you're going to need something that encapsulates the fact that this is a new type that nothing has any kind of knowledge of, and you're probably going to need to have a chain of what those things are dependent on an existing known static. I say static, I don't mean C# terms, but in terms of, what you're working with on your backend, static types that your entity, that your data source is aware of. and you're going to need that whole chain in order to get there.
You're
so
saying
I would say at this point, that's probably the job of the broker, the thing that's generating the expression trees, right? Because
right, and I'm saying
that point,
it's a further concern. But
but
the thing is, if you parse these out, this is going to naturally unfold from all of this. Right.
We don't know. Like if you stay, if you know, to Nick's point, yes, it's good that we know this is coming because it may influence our decisions today. But from a tokenization standpoint, it seems like the way Paul described it in putting a nested nodes and just putting them all in one array and then represent it as JSON. Oh my God, Paul, do you know how easy this is to debug and for people to understand? If I tell people, here's a parser, here's a service, check this out, Sam. So here's a service, and here is your JSON that represents that query that you just passed in. People will take that and build websites that say, just enter your OData query and turn it into. I know that JSON. I'm gonna go make my own implementation to go implement, you know, OData querying and turn it into. Oh my God, this is just.
Well, what if I wanted to provide a bit of UI that allowed users to build their own custom queries, and then I can input that blob of JSON as the configuration for a grid of data on a web page, for example? You know, I see a lot of stuff. Telerik are doing things with Kendo UI, for example, right? The way that their parameters and things are built up. If we standardize the fact that an OData query could be turned into a JSON blob like that, and said to them, hey, in the event that you build an OData data source, if I give you one of these, what are you going to do with it? And they're going to go, great. That's perfect. That's
exactly what. You know, by the way, you know, I have the Oasis people waiting on me saying, if you do something too generic, let us know so we can standardize it. So we tell everybody, this is how you can, right, Sam? I
want the output of our internal models to be a JSON blob. So we can say to people, hey, here's what the OData looks like. Here's what the JSON looks like. And it easily translates to XML if you want XML or
anything. YAML. So I can turn it back into C#. I had a friend of mine. I'll tell you, this is real true story. I have a friend of mine. He was like doing this interview, and the guy said to him, "Build me an ASP.NET Core API." He's like, "Oh yeah, easy peasy. That's just simple." And have it return the response in YAML. And I was like, why? That's just a punishment for the guy. You know, it's just okay. It's a serialization thing, super easy, but you know, like YAML, like who needs that? Anyway.
Well, now we have a use case for it.
And now we have a use case for it. So anyway, let's hang out again tomorrow. This is so fun. I hope you guys are having so much fun out of this. I'm having a lot of fun. You know, here's what we can do tomorrow, Sam. We can work with that node and we start writing unit tests, right? A node that has a bunch of nodes as children, and each one of these nodes, it may be just a static value, or it could be a constant, it could be an operation, it could be a nested. You know, we can determine all of that. And let's just write a service that does that mapping. I'll give you a failing test, and you know, we'll keep passing it back and forth and see how far we can take it. What do you think about that? Yeah. And for you too, Nick and Paul, you guys are awesome. Thank you so very much. It's always nice to bounce ideas off of engineers, right? You know, just give people the ideas. Sam is coming in with all this experience. He built the damn library from scratch. He knows exactly what are we gonna face. Like Sam is like, have you guys seen that episode, that movie called The Emperor's New Groove? You know, where Pacha and you know, they were like, hey, you know, don't tell me there's like sharp rocks at the bottom. Bring it on. It's like, yeah, we're going down. So this is where Sam is like, by the way, there is sharp rocks at the bottom. Just letting you guys know. You have dreams. It's beautiful, but I want to tell you how this is gonna end. I appreciate all of you. This is really fun, and I look forward to connecting with all of you tomorrow. And for people watching us, please, if you want to engage with us in these discussions, this is a community effort, you know, where we get to just go out there in this R&D amazing hackathon, never-ending hackathon, and we try to build something that may or may not be amazing. Talking to Daniel Roth yesterday, I was so inspired. He said to me, you know, Steve Sanderson, he was just playing with some JavaScript and WASM, you know, libraries, and he's like, what if I could run C# in the browser, like as a flex? He's like, you know these folks that run, freaking Doom on a pregnancy test, whatever they're doing these days. That's literally what he was doing. He said, "Can I run C# in the browser?" And then that turned into Blazor. So you never know what comes out of this. And I always think big. I try to think how much people can I help, with these initiatives. For people watching us, if you have any questions, comments, or concerns, please feel free to drop a comment in the comment section. Don't forget to join our Discord channels if you have any questions, and don't forget to like and subscribe. Thank you guys so much. I'll see you in another video. Take care. You guys are awesome.